In this 9-4 lesson, we're going to learn our fourth method, right? So we've talked about graphing, we've talked about factoring. Yesterday we discussed solving by square roots, but we understood there's a limitation to which ones work for that, right? And now this fourth choice is called completing the square, okay? Now before I get into all of this stuff on completing the square, I want to just walk you back a second so you kind of see the domino effect of the stuff you've learned up until this point that's going to help you, complete the square, in other words, right? So, especially last night, for example, on the end of the homework problems, I just reminded you, that when you have something that looks like this, if and when you recognize that that's a perfect square trinomial, if your quadratic is a perfect square, the quadratic version of 100 or 81 or 144, right? Those perfect square numbers. If your quadratic is a perfect square, then it has that nice pattern where this is a perfect square, that is a perfect square, and this middle term is the square root of those two things times 2, right? That's always that pattern. That pattern has been kind of looping back into our lives over the last couple of months over and over again, okay? And that pattern then says, hey, so when you have that perfect square quadratic, that factors pretty easily into the square root of that first term, this middle sign right here, and the square root of this guy, right? So then we can rewrite that perfect square trinomial in factored form as a power, okay? And that's what you practice on those last 5 or 6 problems on the homework. Does everybody feel okay with that? And it's all review. But then what I want to connect for you is the fact that if you have a perfect square trinomial like this that you can write as a factored form here, power, okay, then we can take something that looks like this and use the square root method on it to solve it. And we had a handful of problems like that on our notes and on the homework, right? So we had a couple of problems where it started off looking like this, and we were able to just take the square root of that whole thing, drop that, and get it down to a pretty simple one-step equation. Yeah, remember that? So that's what we're looping. So really, yesterday when I said that the square root method only worked on quadratics where b was 0, it was a little bit of a lie, tiny lie. There's a little part of that was a lie, because the exception is the perfect square trinomial. If you have a perfect square trinomial that you can rewrite as a perfect power, right, a squared power, then you can still use the square root method on that, like we did yesterday. Everybody good with that? Yeah? Okay. And that made the problem pretty easy. Being able to, instead of having to FOIL, let's talk about this guy right here, right? Instead of having to FOIL that and then find, figure out the trinomial and then use all these other methods, it was pretty nice to just be able to kiss that power goodbye and just end up with a one-step equation, x minus 7, where all I had to do was add 7 and we were done, right? It was a nice thing to be able to just get rid of the whole quadratic aspect of it and just get it to a simple solving x kind of equation. This is our goal today. Our goal is to have perfect square trinomials that we can write as factored form powers that we can then use the square root method on. Okay? That's our goal. Now, is every single quadratic a perfect square? No. So what you're going to learn today is how to make them be perfect squares. That's today's lesson. Today's lesson is going to be, how do I take a regular, ordinary quadratic that's not a perfect square, and how do I force it to be a perfect square so I can do this to it? Okay? And I do promise, once you get the hang of it, it is worth it for some problems. But I also want to say that although completing the square is one of the options for solving quadratics, it actually has other uses in math. You're going to see on Monday, we're going to use it to write vertex form. And when you get to Algebra 2 Pre-Cal, you'll see that completing the square has more uses than just solving, or more, more advantages. So it does have other stuff that is kind of cool about it too. The last thing I'm going to say about completing the square is it is one of the methods that works no matter what. But I'll say that with a little disclaimer asterisk, right? It does work on every single quadratic. However, it can get really messy for some quadratics. So yes, it'll work for any quadratic. No, you probably will not want to use it for every quadratic. Okay, there are some, and you'll see some examples later that you would not want to go with this method if you had any choice. It will still work, but it can get messy. So there you go. All right, so now let's really talk about how do we create a perfect square when we don't have one, a perfect square trinomial, right? That's called completing the square. Okay. And what we want to do is essentially guarantee that pattern that I just showed you, that if I took the middle term and I got half of it and I squared it, that would be my C term, because that's where the magic is. That's what makes it a perfect square. So we're going to practice just creating that, and then we'll see how we can solve equations with it, okay? So when we want to create something so that it's a perfect square, we want to take that the first term needs to be just x squared. One of the big things, x squared. So that means that a is equal to 1. And then we want to look to see what this second term is and do the following things. I want to take that second term and first of all, take 1/2 of it. Because remember, that got doubled. So I'm going to take 1/2 of it to find out what that original number was. And then I'll take that result and I'll square it. And then whatever that gives me, I'm just going to add that on to the end of the quadratic. And I will have a guaranteed perfect square. Okay? I will have a guaranteed perfect square. So let's see what that looks like. We're just going to practice a few here. Okay? This is just baby steps kind of to practice the method. Okay? So we have the first two terms. Make sure a is equal to 1 right here. So we're good there. And then what we'll do is we'll take this second term in the equation and we'll divide that by 2. What's negative 14 divided by 2? Negative 7. I think I did this one as the example earlier, but that's fine. So negative 14 divided by 2, that gives me negative 7. Then I'll take that negative 7 and I will square that, and that will give me 49. And that is what I will add on to the end of this to create the perfect square trinomial. So adding that 49 on to the end of the first two terms at the end as a constant guarantees me now that x squared minus 14x plus 49 is a perfect square trinomial. And I then can factor it because I understand the relationship here. So this is my perfect square trinomial now. And if I write that in factored form, it's the first term, the square root of the first term, that middle sign, and the square root of that guy. So this would be the factored form version of that. Okay? Yes? So you always divide, you always take 1/2. You always take half of it. So you're just taking half, I'm dividing it by 2. So that part is always constant. You take half of the B term, the middle term. Mm-hmm. Yeah. Parentheses. Yes. Yes. So kind of like, so did y'all hear what Katie asked? That's a pretty good question. So she's asking, is it always kind of this number that we kind of land on in the middle, after dividing by 2 before squaring? Yes. That number always ends up being the number there. Okay, because that's the number that we are doubling here to get here and squaring to get there, right? So this is the number that's getting multiplied by 2 to end up in the middle term, but getting squared to end up there. So when I'm writing it in factored form, it's going to be what goes right in here. Okay? All right, let's try the next one. So if I have x squared plus 12x, and I want to finish that off to be a perfect square trinomial, I'll take this middle term right here. I'll take that 12 and divide it by 2. Oops, I don't know why I did that. Okay, so 12 divided by 2 is 6, and then I'll take that and square it. What do we get? 36. So I know that as long as I put a 36 at the end of this, this is now a perfect square trinomial. And the factored version of that would be what, guys? X plus 6 to the second power. Okay? Once you get the hang of it, it's not too bad, right? Let's try the number 3, right? We'll take that 4 in the middle. We'll divide that by 2. What's 4 divided by 2? 2. And then when we square that, we get 4. So as long as I add a 4 on the end here, this is a perfect square trinomial. What would be the factored version? X plus 2 squared. That is what that is. That is called completing the square. Okay. We'll do 4 really quickly because now we have the hang of it. And then number 5, you start to see, oh, this is where it's like a little messier, right? So let's do 4 real quick. If we take that 18 and we do 18 divided by 2, what do we get? 9. And then we take that 9 and we square it, we get 81. So as long as I have an 81 on the end of this, we have a perfect square trinomial that we know will factor into x plus what, guys? 9 to the second power. Okay? Now, that's called completing the square. So you just completed the square 4 times. That's it, right? We haven't solved anything yet with it, but that's the steps for completing the square. Okay? What do you notice about number 5? It's not an even number, right? That's not going to stop us, but you can just start to see where things start to get just a little bit less friendly, and that's why completing the square works all the time, but sometimes it's not your friend, and you're probably better off with a different method. So, but let's do it because this is still pretty doable. So nothing changes if your b term is odd. We're still doing what we're doing, okay? We're going to take that -7. We're going to divide it by 2. Okay, that doesn't go in. I like fractions. It's no secret. Y'all know me. I'm going to leave it like that. If you're really big on decimals and you really feel the need to make that a -3.5, do that. That's okay. Okay? But I like fractions, so I'm going to leave it like that. And then what would I do after I divide by 2? I square that. So it doesn't change a thing as far as what I'm doing. I'll square this and I'll get 49 over 4. So a 49 over 4 at the end of this trinomial, believe it or not, is a perfect square. That is a result of something times its identical self. And in fact, that something happens to be x minus what, guys? 7 over 2. Yes? What do you mean in your last equation?
So whatever we do divided x plus 2 squared.
Yeah, so every time, whatever you divided by 2 and whatever you got there is what ends up being in the parentheses.
So you don't really have to how to...
You will, because you'll see in a second. So the reason you're going to really need that 30, I see what you're saying. Could I just jump to the parentheses? The problem is that in a moment, we're going to solve what? What do we solve? Things that have equations, right? And if I have an equation, it's a little different because in an equation, if I decide all of a sudden, I just want to add a 36 on this side, what do I have to do on the other side? Right, so I have to know that 36 because I have to make sure I do it to the other side of the equal sign. If not, then yeah, you're right. You could just go right into that. You'd really just be factoring, which is what you did last night, all right? So you would really just be factoring at that point. We do need that C value because we're going to need to make sure that we add it on both sides of the equality and keep things balanced. So, okay. All right. How do we feel about those? Okay. All right. Last one. We'll do this one pretty quick. We'll take that 11 divided by 2. You can then write this as 5.5 or leave it as 11 over 2. You decide. 11 over 2 is just 11 over 2. And then I like to square it as a fraction. So I get 121 over 4. So if I just add 121 over 4 here, that is a perfect square trinomial. And the factored version of that, I'll write down here, is x plus that 11 over 2 to the second power. Okay? All right, so do we feel good with just the method, the steps for completing a square? Are we good with that? Okay, then let's use it to solve, because I think that will start answering some of these questions, right? So now let's put it into Let's put it to work, right? Let's put it into action. So we're going to use that we just did to actually solve quadratic equations by completing the square. We're going to write our solution in both simplified radical form and decimals if they don't come out nice whole numbers. And when it's a decimal, we'll round to the nearest hundred. So we'll get there in a second. So first of all, okay, look at your quadratic and make sure it's ready to be, for completing the square. Make sure a is equal to 1. And make sure there isn't an unwanted c constant. If there had been, let's pretend for a moment that 15 had been on the left side. Okay, if 15 had been on the left side, then it's just in my way. It's not a perfect, x squared minus 8x plus 15 is not a perfect square. If you end up with a trinomial and you're looking at it, it's like, this isn't a perfect square, I need a perfect square, then just grab that c and get it out of the way by moving it to the other side. So you can insert what you want in there. Okay? So, but this one doesn't, we don't have to worry about it. There's no c value. It's already written as x squared minus 8x. I'm just going to leave an open space here where I'm about to complete the square. But I want to make sure whatever I add on that side, I have to also add to the other side. Does that make sense? Okay. So what completes the square here? Let's find out. What would complete the square here for us if we take that negative 8, divide by 2, and then square that result? What do y'all think? Are we all okay with 16? Okay, but again, this is a little different now. If I add 16 on one side because it's an equation, I have to make sure I keep this a true statement and I keep it balanced and equal. I add the 16 on the other. That's why we need it. Okay, so now that I've added it on both sides, though, I now have a perfect square trinomial on the left that I can rewrite as the factored form power. Okay, so because we created a perfect square trinomial, I can write it in factored form as x minus 4 to the second power. And then on the right side, what's negative 15 plus 16? Just 1, okay? And now it becomes like last night's homework or last night's notes, right? Now we have a perfect square power on one side, and all I have to do is take the square root of both sides, okay? So I can come in here and say, oh, I'll just take the square root of this side and that side. And that completely, cancels the 2 here. And so we just get x minus 4 is equal to the square root of 1. What's the square root of 1? Positive or negative 1. There it is. Okay. And the rest of this is review. It's history, right? You can either set up 2 different equations and just solve, x minus 4 equals 1 or x minus 4 equals negative 1, and then just add 4 on to solve it. So one of our solutions here is x equals 5. The other one is x equals 3, right? Or you could have added the 4, but just make sure you realize it's one of your answers is 1 plus 4, and the other answer is negative 1 plus 4. Okay? But there you go. Now you solved an equation using completing the square. Okay, let's try the next one. This guy right here, a is 1. There's no constant, so we'll just go ahead and rewrite this and make a little bit of room to complete the square. And what completes the square here? If we take negative 16, divide that by 2, we get what, guys? Negative 8. And then when we square that, we get 64. So what we want to add on both sides here is a 64. That will complete the square on the left, give us a new answer on the right. Okay? So I can rewrite the left side now as a perfect square power, x minus 8 squared. On the right side, negative 15 and 64, I believe, is 49. Right? And because I wrote that as a perfect square power, I can now just take the square root of both sides and turn this into a very easy problem. Square root. This cancels the power. So x minus 8 is equal to the positive and negative root of 7. And then I can just add 8 on both sides. This is the other way you could solve for x here. Just remembering that x is equal to two different things. Positive 7 plus 8, which is 15, and negative 7 plus 8, which is 1. Okay? How do we feel about that? Yes. Well, you have lots. You'll have 5 total ways at the end of the game. You could. These are all both factorable. You could have done graphing. The square root only if you complete the square. But that's the whole point. I mean, once a quadratic has a solution, they all work. You have lots of options. So yeah, you probably are. But today you have to do completing the square. That's like the lesson today and what we're going to practice. But square it. Factored it, right. So we want you to use, so completing the square, once you get it like this, the idea is to make the perfect square in order to, because you could have set this equal to 0 right now without completing the square. Okay? So the whole point is to use it to make that perfect square. Yeah. Mm-hmm. There are 5 problems that will literally test the 5 methods. Every other problem on the test, the rest of the other, whatever, 15 or 20, you can, whatever method you want. Yes, right. So it'll be like number 17 says solve by quadratic formula, and it gives you that problem, and that's the only way we'll pick that problem. But then all the other ones that just say, how long did it take the ball to reach again? It doesn't say what method. You could use it, whatever method you think. And that's part of the idea is you start to realize which ones lend themselves more easily to, oh, this is a really good candidate for this, or this is, and you do get, freedom of choice on most of the tests, but there is a section that assesses and tests whether you know each method. It's really testing that you know the method more than anything else. The rest of them, you can use whatever you want. Mm-hmm. Okay. All right. So are we okay with that one? Ready for the next ones? Okay. So if you haven't already, try number 9. Okay, there's a little typo number 10, so we'll fix that in a second. Okay. Let's go ahead and get to let's do number 9, and we'll probably, no, actually, you know what? Have y'all started 9 already? Okay, go ahead and finish number 9 real quick. We're going to do it fast. Okay. So we'll do negative 26. We'll divide that by 2. We get negative 13. When we take that negative 13 and we square it, we get 169. I guess it's good that we did this one. 169 on both sides is what we want to add. That creates a perfect square trinomial, and it lets us rewrite that in this particular method, right, as a power. On the other side, negative 9 and positive 169, it's just 160. Okay. We'll take the square root of both sides to cancel the power. And in this case, is 168 perfect square? No. Does it have a perfect square factor? Yes, what? 16. It's the product of 16 times 10. So we are leaving it in simplified radical, and then we'll do decimals. But so we want to make sure we do this correctly. So we'll split it up into 16 and 10. What is the square root of 16? 4. So we really can rewrite this as plus or minus or positive or negative 4 square root of 10. Okay? And then our last step can then move the 13 over. So we'll move the 13 over by adding 13. However, quick reminder, can I actually add 13 with 4 square root of 10? No, they're not like terms, right? So we really are just going to leave our answer as just 13 plus or minus 4 square root of 10. That would be the radical version, the simplified radical form version of our solutions right there. Okay? It would be 13 plus or minus 4 square root of 10. That is fully simplified, or as simplified as we can get it. And then we'll go to the decimal. That's just a matter of putting that in the calculator. I believe for the decimal piece of this, we get 25 0.65 and 0.35, I think. Is that what y'all got? Okay. All right. Okay. Sorry. Minus. Okay. Look at number 11. What might be throwing you off a little bit on number 11? A is not equal to 1, and there's a C value that is not making this a perfect square. We got to fix both of those things, okay? So step number 1, listen, this is why I wanted you to do this one with me. Move this, if that C value is there and in the way and not what you want, move it to the other side. And the second piece of this is if there is an A value here, you have to divide it out. It doesn't even matter if it goes evenly. You cannot complete the square if A is not 1. Okay? So I have to divide that out of the way, even if it results in some fractions or decimals. Okay? So I got lucky here on the left side, it does divide, and I'll just leave the blank here for completing. Over here, I'm just going to have a third, and that's okay. Okay? Now I can complete the square and do 2 divided by 2, which is 1, and 1 squared is still 1. So I'm going to add a 1 on both sides. And that lets me then create the perfect square. This is a perfect square trinomial that just factors to this. 1/3 plus 1 is 4/3. And then you can take the square root of both sides. So then we take the square root of both sides here. Drop that power. We get x plus 1 is equal to the positive or negative root of 4/3. Now, for simplified radical, remember, we can't leave fractions, so this takes a little bit of simplifying here. We'll separate out our radicals to the top and bottom, and then we will rationalize that denominator by turning it into a perfect square. Oh, and by the way, square root of 4 is just 2, right? So on the top, I get 2, because this square root of 4 is just a positive 2. So I get 2 times the square root of 3. And on the bottom, I just get 3, because square root of 3 times square root of 3 is 3. And that is a simplified version of the radical piece of this. So I'm going to come up here. I don't have a whole lot of space. So up here, I now have x plus 1 is equal to the positive or negative 2 square root of 3 over 3. And then I just move the 1 over to the other side. So x is equal to negative 1 plus or minus 2 square root of 3 over 3. And that would be how we would write our answer. When we're leaving it in simplified radical, it is also can be solved as a decimal if it asks or if it wants both. When you evaluate this decimal, you get right at about 1500 and negative 2 and 1500. So that would be the decimal equivalent. All you would have to do is take this and insert it into the calculator. You have to do them individually. Negative 1 plus 2 square root of 3 over 3, and then do negative 1 minus 2 square root of 3 over 3. But those are your results. So that is the solutions to that quadratic. All right, on number 12, this one's going to probably take a little bit more space. So I'm probably going to do it on a clean slide here. I'll recopy the problem at the top. We've got 12x squared minus 8x minus 2, and then 0 on the other side. Okay? So, again, you could either move the 2 first and then divide both sides, or you can start off right away by dividing both sides here by a. Either way, you have to get rid of the a term. That's the first big idea here. Get rid of the a term so that it's equal to 1. And then when I divide everything here, I get x squared. In the middle, I'm going to get 8 over 12, which is 2/3. So it's a negative 2/3 here. And at the end, I'm going to get a negative 2 over 12, which simplifies to a negative 1/6. On the other side, 0 divided by 12 is still 0, so that's not too bad. Okay, so I just divided everything through by 12 so that a is 1. The next step is to move that 1/6 So we now have x squared minus 2/3 x. I'm going to leave a blank here to complete the square in a moment. And 1/6 on the other side. I'll have my same blank so I don't forget. And we can start the process of completing the square. So when we take that 2/3, this is a side note, right? When we take that negative 2/3 and divide that by 2, okay, we just get negative 2/6 or 1/3. So negative 1/3. And then when we square that, we're going to get 1/9. So that's what completes the square here. Adding 1/9 to both sides. That's a perfect square now. And then I can now rewrite that trinomial. X minus the square root of 1/9, which is 1/3. On the other side, I'll get 1/6 plus 1/9. Make sure you have a common denominator. All that good stuff. That ends up being 5/18. Just for the sake of time, I'm going to jump right to that. Just know that, well, let's do it. So times 3, if I take this and I multiply it by 3, I get 3/18. And if I multiply that by 2, I get 2/18. That gives me a common denominator, and I can add them together. So I get 5/18. Okay, we'll take the square root of both sides. And we'll end up with x minus 1/3 is equal to the positive or negative root of 5/18. And of course, that's not simplified, so we'll clean that up in just a moment here. I'm going to do that just with the radical itself. First, we always separate the radical to the numerator and the denominator. And then in the denominator, I just want to create a perfect square here. So I can just multiply by square root of 2. That gives me a square root of 36 down there. That'll be a perfect square. So now I've got square root of 10 on the top. And on the bottom, I get square root of 36. The whole point there is always just to get that perfect square. And that leaves us really with just square root of 10/6. So as a simplified radical, I'll bring this all up here. Right, we've got x minus 1/3 is equal to positive or negative square root of 10/6. And then we just add this to both sides. And we get x is equal to 1/3 plus or minus the square root of 10/6. And that would be our final answer if we're leaving this in simplified radical form. If we're writing it as a decimal, then we just reach for our calculator and evaluate both of those solution options. One of them, I believe, comes out to about 8/600, and the other one comes out to about negative 19/100. Okay? And that would be the decimal version of the same solutions.